Hi to everyone, myself Dr. Dhananjay Rao, working as Assistant Professor in the Department of Chemistry. Today's topic is mechanism of lubrication. See, in this video I am going to cover lubricants, characteristics of lubricants and mechanism of lubrication like thick film, thin film and extreme pressure of lubrication. These are the different types of mechanisms involved in the lubrication. We are going to cover these topics in this video. See, what is meant by lubricant? In all type of machines, the moving surfaces rub against each other. Due to this rubbing, a resistance is offered to their movement. In all type of machines, what happened? The moving surfaces. If two moving surfaces are together, what happens? These are rub against each other. The moving surfaces rub against each other. Due to this rubbing, a resistance is offered to their movement. This resistance is known as friction. This friction will cause a lot of wear and tear of surfaces of moving parts. This resistance is known as friction, and this friction will cause a lot of wear and tear of surfaces of moving parts. Due to the friction, large amount of energy is dissipated in the form of the friction. Due to the friction between two moving surfaces, the large amount of energy is dissipated. In the form of the friction. Okay. Large amount of energy is dissipated in the form of heat. Thereby, the efficiency of the machine gets reduced. Due to the large amount of energy is dissipated in the form of heat. Thereby, the efficiency of the machine gets reduced. What is lubricants? Lubricant, already we discussed in the previous video. Lubricant is a substance. It reduces the friction between the two moving surfaces. Okay. In all type of machines, the moving surfaces rub against each other. Okay. Because of these moving surfaces, these both rub together, so it will produce some resistance. The resistance is offered to their movement. This resistance is known as friction. The resistance between two moving surfaces is called friction. This friction causes a lot of wear and tear of the surfaces. Due to the friction, of large amount of energy is dissipated. Because of this friction, the large amount of energy is dissipated in the form of the friction. Large amount of energy is dissipated in the form of heat. Thereby, the efficiency of machine gets reduced. Because of this friction, the efficiency of the machine will get reduced. The lubricant is a substance used in between two moving surfaces to reduce the friction. Lubricating is a substance used in between the two moving surfaces to reduce the friction is called lubricant. What is meant by lubrication? The lubrication is a process of reducing the friction and wear and tear between the two moving surfaces by adding lubricating between the two moving surfaces. Lubrication is a process of reducing the friction and wear and tear between the two moving surfaces. The functions of lubricant. What are the functions of the lubricant? It prevents the direct contact between the moving surfaces and it reduces the wear and tear, and it prevents the surface deformation of the concerned parts. It prevents the direct contact between the moving surfaces and it reduces the wear and tear, and it prevents the surface deformation of the concerned parts. It reduces the wastage of energy so that the efficiency of the machine enhanced. It reduces the waste of energy so that efficiency of the machine enhanced. It reduces the frictional heat and prevents the expansion of metals. It acts as a coolant by the moving the frictional heat generated due to the rubbing of surfaces. And it minimizes the corrosion. These are the characteristics of a good lubricant. See, what are the characteristics of a good lubricant? A good lubricant should not undergo any decomposition. And oxidation reduction at high temperatures. A good lubricant should not undergo any decomposition and oxidation reduction at high temperatures. A good lubricant should have higher flash and fire points than the operating temperature. A good lubricating should have higher flash and fire points than the operating temperature. A good lubricant should have higher flash and fire points than the operating temperature. A good lubricant should not corrode the machine parts. A good lubricant should not corrode the machine parts. A good lubricant should have high oiliness and viscosity index and aniline point. A good lubricant should have high oiliness, viscosity index and aniline point. What are the characteristics of a good lubricant? A good lubricant should not undergo any decomposition or oxidation reduction at high temperatures. A good lubricating should have higher flash and fire points than the operating temperature. A good lubricant should not corrode the machine parts. It should not corrode the machinery parts. A good lubricant should have high oiliness and viscosity index and aniline points. These are the characteristics of the good lubricant oil. See, the mechanisms involved in the lubrication or types of the lubrication. See, the lubrication film between the two contact surfaces is thick enough and the two contact surfaces are separated completely by viscous oil film. The lubrication film between the two contact surfaces is thick. Two surfaces are there, in between lubricant film is there. Okay, now we have applied lubricant oil. Okay, the lubrication film between this is called lubrication film. Okay, these two moving surfaces are separated, or in this we have to fill with the lubricating oil. Okay, that is called lubricating oil. It forms a film. The lubrication film, that is called lubrication film. The lubrication film between the two contact surfaces is thick enough. This is thick enough, and the two contact surfaces are separated completely by viscous oil film. These two surfaces are separated by the viscous oil film. At this time, the frictional force of two contact surfaces are determined by the viscous resistance of lubricant, and it can be take a very small value. Coefficients of frictions can be 0.0001. Okay, what happens? At this time, the frictional forces of two contact surfaces are determined. In this case, we have to determine the frictional forces between these two surfaces. Okay. The mechanism of the lubrication. There are three types of lubrications are there. Mechanisms of the lubrications are there. Three types of mechanisms are there in the lubrication. The first one is thick film or fluid film or hydrodynamic lubrication. The first one is thick film. We can also call fluid film or hydrodynamic lubrication. This is the one type of mechanism in the lubrication. The second one is thin film or boundary lubrication. Thin film or boundary lubrication. The third mechanism of the lubrication is extreme pressure lubrication. The third one is extreme pressure lubrication. The mechanism of lubrication are three types. Or types of lubrications are three types. Those are thick film or fluid film or hydrodynamic lubrication. The second one is thin film or boundary lubrication. The third one is extreme pressure lubrication. This mechanism, the lubrication mechanism is classified into three types. That is thick film. The greases, Vaseline are example for the thick film mechanism. This form the thick film in the two moving surfaces. The next one is thin film. The blended mineral oils. The blended mineral oils are example for the thin film. The extreme pressure, in the case of extreme pressure mechanism, these are the example. Oil with the chlorinated esters. These are the examples for the extreme pressure mechanism. Okay, there are three types of mechanisms are involved. See, thick film or fluid film or hydrodynamic lubrication. This is the first type of mechanism of the lubrication. Okay, the condition under low load at high speed. Okay, it works at under low load and high speed. This film, thick film lubrication mechanism applicable for under low load and high speed. Okay, under low load and high speed, the thick fluid film of lubricant is maintained between the two solid surfaces. Under low load and high speed, under this condition, under low load and high speed conditions, a thick fluid film of lubricating is maintained between the two solid surfaces. In between two solid surfaces. Okay, at what conditions? At low load. The load should be low, and these are contain high speed. Okay, this is moves this side, this moves this side, and this movement is should be high speed. Okay, then if you apply the lubricant oil, okay, it maintain the thick fluid film. In this moving surfaces, it maintain thick fluid film. What condition it maintain thick fluid film? At low load and high speed conditions, it maintain the this thick film. Okay, the thickness of fluid film at least 1000 angstroms. The thickness should be 1000 angstroms. The thickness of the fluid film is 1000 angstroms. Since the thick fluid film separates the two solid surfaces, there is no direct contact between the solid surfaces. Because of this thickness, the thickness should be more than 1000 angstroms. Okay, na? Then what happens? These two solid surfaces are there is no contact between these two solid surfaces. These two are separated by this thick film lubricant film. This reduces wear and tear. Is no direct contact between the solid surfaces. Because of there is no direct contact between these two solid surfaces, then it reduces this thick film fluid reduces the wear and tear between these two solid surfaces. The coefficient of the friction of in such cases is low, that is 0.0012 to 0.03. The coefficient of the friction it maintained 0.0012 to the 0.03. See, this is one moving surfaces. This is one moving surfaces. In this we have applied the lubricating oil. Thick layer will be formed, that is 1000 angstrom thick film. At what conditions it should work? At low load and high speed conditions, it maintain this mechanism followed. That is thick film or fluid film or hydrodynamic lubrication. At what conditions it works? It should contain under low load condition and high speed condition. Low load and high speed you have to apply. The thick film should be 1000 angstroms, more than 1000 angstroms. The thick film or fluid film hydrodynamic lubrication. Example, consider the rotation of a shaft with a respective to a stationary bearing. See, it is a bearing lining, and this is the rotating shaft in floating lubricant, and this is the lubricant oil, thick film of lubricant. Okay. Example, if you take thick film mechanism, you can observe in the rotation of a shaft with respect to the stationary bearing. When a lubricant is added to the system, it occupies the annular surface between the shaft and the bearing. This lubricant oil occupied the between this bearing and the shaft. Okay, in between the bearing and shaft, the lubricating oil is applied. When a lubricant is added to the system, it occupies the annular surface between the shaft and the bearing. Okay, it occupies the annular space between the shaft and the bearing, and it forms a hydrodynamic lubricant film. Okay, it prevents the contact between the two solid surfaces. It prevents the contact between bearing and shaft. When the load becomes very high, if you apply very high load, the lubricant will be squeezed out of the wedge. This lubricant oil comes out. Okay, the lubricant will be squeezed out of the wedge and friction will occur. Then these two shaft and bearing will undergo direct contact. Okay, in this way the load the resistance of the friction will be increases in the case of shaft and this bearing when we applied the high load. See, when the load becomes very high, the lubricant will be squeezed out of the wedge and friction will occur. In the case of thick film, fluid film or aerodynamic lubrication. The thick film or fluid film aerodynamic lubrication condition is under low load and high speed. Okay, it under low load and high speed. If you apply high load, it will not work. Okay, the resistance will be increased or friction will be increases between these two moving surfaces. The next mechanism, the second mechanism is thin film or boundary lubrication. Thin film or boundary lubrication. The condition in this case is under high load and slow speed. Under high load and slow speed. Under the conditions of high load and slow speed, a continuous fluid film cannot be maintained between the moving surfaces. Under the conditions of high load and slow speed. Under the conditions of high load and slow speed, a continuous fluid film cannot be maintained. The continuous fluid film can be maintained at these conditions. At what conditions? Low load and high speed conditions only we can maintain the thick film. But in case of high load and slow speed conditions, we can't maintain this continuous fluid film. Okay, this continuous thick film. Okay, that's why this film cannot be maintained between the two moving surfaces. Under such conditions means under high load and slow speed conditions, the thickness of the fluid film should be less than 1000 angstrom. Okay, under such conditions, under these conditions, under high load and slow speed conditions, the thickness of the fluid film should be less than 1000 angstrom. Such a thin film consists of 2 or 3 molecules thick. Such a thin film should consist 2 or molecules thickness it should contain. To form a thin film of the lubricant has to be adsorbed on the metal surfaces by physical or chemical forces. To form a thin film between the two moving surfaces, okay, to form a thin film of the lubricant has to be adsorbed on the metal surfaces by physical or chemical forces. This lubricant oil can be adsorbed on these metal surfaces by these forces, physical or chemical forces. In some cases, the lubricant will react chemically with the metal surfaces, forming a thin film of metal soap. In some cases, the lubricant will react chemically with the metal surfaces, forming a thin film of metal soap, which will act as a lubricant. This thin film is known as boundary film. The coefficient of friction in such cases is around 0.05 to 0.15. Thin film of boundary lubrication. The condition is under high load and slow or low speed or slow speed. Under these conditions, high load will not work. And under these conditions, high load and slow speed, the continuous fluid film cannot be maintained between the two moving surfaces. Under these conditions like high load and slow speed, what happens? The thickness of the fluid film should be less than 1000 angstrom. So, in such thin film consists of 2 or 3 molecules thickness. To form a thin film of the lubricant has to be adsorbed on the metal surfaces by physical or chemical forces. In thin film boundary conditions, what happens? The metals absorb this lubricant by physical or chemical forces. In some cases, the lubricant will react chemically with the metal surface. In some cases, the lubricant oil react with this metal surface, form a thin film of metal soap, which will act as a lubricant. This thin film is known as boundary film. The coefficient of friction in such cases around 0.05 to 0.15. See, the effectiveness of boundary lubrication depends on the oiliness of the lubricant. The effectiveness of the boundary lubrication depends upon the oiliness of the lubricant. Oiliness is the ability of lubricant to stick onto the surface. Oiliness is the ability of the lubricant to stick on the surface of the metal. Vegetable oil and their fatty acids have more oiliness. Example: oleic acid, stearic acid. These are the fatty acids. Okay, these are contain oiliness. The polar group of carbonyl, that is COOH, of these oils react with the metal surface to form a continuous thin film of lubricant. The oil like oleic acids and stearic acid, it contains the polar groups like carboxylic acid. It will react with the metal surfaces and forms a thin film. Okay, thin film of lubricant. The hydrocarbon chain of the fatty acids gets oriented outwards in perpendicular to the direction. See, this is the lubricant oil. The lubricant oil contains like oleic acid. The oleic acid, this round circle indicates with the COOH functional group. These are polar one. COOH is polar one, that is indicated with a circle, and this tail is non-polar. Okay, these all polar. See, these circles are contain polar groups like COOH. These polar groups reacts with these metal surfaces. Okay, these metal surfaces form a thin film. It forms a thin film. Okay, similarly, these polar groups reacts with this metal surface, forms a this type of structures. Okay, see, hydrocarbon chain of the fatty acid gets oriented outwards in perpendicular to the direction. See, to this metal surface in the perpendicular direction, these non-polar groups are adsorbed, and in the polar groups are reacts with the metal surfaces. It forms a thin film. Okay. See, this is a solid surface, this is the ordered film, and this is the fluid film, and this is the adsorbed film in the case of thin film boundary lubrication. The third mechanism of this lubricant oil is extreme pressure lubrication. Extreme pressure lubrication. It works at under high load and high speed conditions. Under high load and high speed conditions. Under the conditions of high load or high pressure, high load nothing but high pressure, and high speed, more heat is generated between the moving surfaces. Under the conditions of high load or high pressure and high speed, the more heat is generated between the moving surfaces. As a result of this, the liquid lubricant fails to stick and undergoes decomposition. As a result of this, the liquid lubricant fails to stick and undergoes decomposition or evaporation. The decomposition or evaporation takes place under these conditions, under high load and high speed conditions. Under these conditions, for effective lubrication, special additives known as extreme pressure additives are used along with the lubricants. Okay, to stop the decomposition or evaporation, to this lubricant oil, you have to add some additives. Okay, chemical additives you have to add. Okay, for effective lubrication, special additive known as extreme pressure additives are used along with the lubricants. Okay, the important extreme pressure additives are organic compounds having active radicals or groups such as chlorine and sulfurized oils, etc. The important extreme pressure additives are organic compounds having active radicals or groups such as chlorine or sulfurized oils. These are the additives we have to add to the lubricants. These compounds react with metallic surfaces to form a metallic chlorides and sulfides, etc. These chlorides and sulfurs additives are reacts with these metal surfaces. These compounds react with the metallic surfaces to form metallic chlorides and sulfides, etc. These metallic compounds possess high melting points and serve as a good lubricating under extreme pressure conditions. These metallic compounds possess high melting points and serve as a good lubricating under extreme pressure conditions. These metallic compounds possess high melting points and acts as a good lubricating under extreme pressure conditions. The condition for the extreme pressure lubrication is under high load and high speed, it acts as a extreme pressure lubrication. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.